To understand why certain topologies exist, we'll look in detail at two types of networks: the LAN, Local Area Network, and the WAN, Wide Area Network. The LAN is a network that is limited to a geographical space, for example, a building. For us, this means that all the devices that are connected to our internet box form an LAN. And the WAN, in a way, is just a group of LANs. It's through the WAN that we can communicate with people on the other side of the world. Our internet box that forms an internal LAN allows us to communicate with the outside world through the WAN. Let's move on to topologies. There are two types of topology: physical and logical. Physical topology is the physical arrangement of devices in the network, that is, the way they are placed. And logical topology refers to how data flows through the network. Among the main categories of physical topologies, we have bus topology. Here, each workstation, blue dot, is connected to a main cable, red line. In a bus topology, each workstation is directly connected to all other stations in the network. On to the ring topology. Here, the machines of the network are wired in a circle. This way, each workstation is guaranteed to have two neighbors. We have the star topology. This is actually the most common topology. A central device, often a switch, connects computers and other devices in the network. And then there are mesh topologies. In a mesh topology, each network device is wired with many others. This allows for redundancy and better reliability. One of the most important tasks a network administrator must perform when starting to design a network is to create a detailed map. Here we have a network scheme with the most commonly used Cisco icons. It's important to identify the interfaces of our devices. An S for a serial interface, FA for a fast Ethernet interface, and GI for Gigabit Ethernet. On a network diagram, we also represent IP addresses. For example, 192.168.1.0 is the network address. The /24 is the subnetwork mask. The numbers .1 and .2 at the ends of the device indicate the IP addresses of the interfaces. For example, the .1 corresponds to the address 192.168.1.1. We'll now talk about how applications impact the network. Applications can affect network performance, and conversely, network performance can affect applications. There are three types of applications. There are batch applications. In computer science, batch processing is a sequence of commands that can run automatically without any human intervention. FTP and TFTP are considered batch applications. We have interactive applications. These are applications which need input from the user to run. And there are real-time applications. Real-time applications are for things like voice and video communication. They also require human interaction, and because they run in real time, bandwidth is very critical. A single delay on the network can cause a domino effect of problems. This is why for this type of application, we measure and control quality of service, or QoS. When a network implements QoS, it gives priority to certain types of data that have higher bandwidth requirements. For example, the voice over IP, using the internet to make phone calls, or video chat.